The technology that Supernode are developing here, it's for utilities and developers for their toolbox so that they can deliver networks at the scale and pace at which they can deliver generation and the pace at which new demand can materialize on networks. So this is primarily aimed to assist utilities as they endeavour to enable the transition. 6 gigawatt cables were possible in a 1 metre trench. What this project demonstrates is that we have a technology that can do projects of that scale much more competitively than is possible with today's cable technology.
Here in Dublin, it's a centre of excellence for superconductor design. So we're developing things that are new, that are innovative. It starts with material testing and understanding how the materials behave. We can do that at a small scale, and that's what this sample here is. It's fully representative of the manufacturing and assembly process. We'll cool this down in the lab in a representative way. We put those into our design models, we look at the design requirements, and off the back of that, that informs designs. But it's very important to test those designs at an assembly level to understand the interactions between the components and to understand how the materials behave when they're tested in a cool-down cycle that's more representative of how a full-length superconductor will be cooled down.
So in order to decarbonise and meet the targets, the hope of sticking to 1.5 degrees Celsius, we need to electrify. And to electrify, we're going to need bigger grids. And superconductors allow us to roll out those grids at scale and pace and will be an invaluable tool to utilities and system operators as they seek to enable and facilitate this transition away from fossil fuels.
So this is Supernode's first ultra-high vacuum rig. We build a system out of certain types of materials. We want to know how well it's going to perform over time. It will break, so it's designed to be modular so we can take it apart. But we'll break it, we'll load samples into this major sample chamber here, and then we'll power it up with the thermal control units. In Supernode, we kind of get to design our own equipment for our own testing. This one was entirely developed by Supernode and manufactured for us, so it really is very bespoke.
And what superconductors represent is an invaluable tool for utilities and system operators as they seek to meet their customers' and society's needs.
The R&D that we're doing here is sped up significantly by having our own machine. Getting parts through quicker, the more iterations of each part that we can do to find what works best and what is best with the adhesives and the polymers that we're using.
What Supernode effectively do is to extend the range and application of this wonderful technology so it could fit into utilities' toolboxes and solve the types of challenges we face today as we seek to electrify.